Okay, so in this class we'll do this numerical test 12C, class 10, chapter 12, electricity. Okay, so let us start with example 12.3. You'll find this on your textbook starting from page 219. So let me read the question for us. Go open your textbook to page 219. Let me read it. How much current A? So let's deal with the A part first. There are two parts, A and B, right? So just listen carefully. Before we start, these are the formulas that we're going to need here. Okay, so and first one here up to now, that one here, current I is current, I'm repeating, Q charge divided by time T. Second one is potential difference or voltage V is equal to work done by charge transferred Q. Okay, get familiar with the physical terms here. That is I current, Q charge, T time, V potential difference. The blue is work or energy. And then the third one, the Ohm's law equation, famous one. So get familiar with it. V potential difference is equal to I current into R. See, I current. R is a new term, resistance of the wire. Okay. Then fourth formula today, I'm going to put a new one. Is resistance of any wire is always equal to specific resistance rho, this is called rho, specific resistance, into length of the wire by thickness or cross section, which is indicated by A. So these are the two new things here. This is the specific resistance, or it is also called resistivity. This is the thickness, or it is also called cross section or thickness. This is obviously the length of the wire. So let's just indicate them. The length of the wire. So these four formulas, keep it in mind as we do this portion. First one, A, how much current? So as we read the question, let's start writing. I is the one indicating current, so let's just put there current. Maybe you can put I1 because there B, another current you have to calculate. Will electric bulb draw from 220 V source? 220 V. Whenever you see this physical unit, SI unit V, that is the potential difference. So denoted by V is 220 volt is the potential difference. So get familiar with it. Even though the question did not directly say that, we should know ourselves that V means potential difference. Okay, 220 V. Just like rupees 10, then we know the unit there is talking about money, right? So volt means we should know its potential difference, right? Like that. Okay, so if the resistance of the bulb filament is 1200 ohms, so resistance is usually, let's put V1 and R1, 1200, sorry, 1000. Let's do slowly, ohms. Now this is the SI unit of resistance. SI unit of potential difference is volt. SI unit of current is ampere. Get familiar with the SI units also. It's not hard. So with this, we have to find out the current that is flowing in this case. Now look at the formula 1, 2, 3, 4, and 3 is the one that makes V equal to I into R. See, V, I, R. So we can write here, since using Ohm's law equation, or simply Ohm's law, we know V1 will be equal to I1 into R1. See formula number 3. So we're told to calculate the current, so just keep the I1 on its own side and V1, then you shift this R1, then into means numerator will go to the denominator. So here V1, you put the value 2200V. Make sure that everything is in the SI system, that is the same system of unit, otherwise you cannot cancel, right? So just like you cannot cancel rupees 100 by $20 because they are different units, so we have to convert the dollar to rupees or rupees to dollar, and only like that. So everything has to be in the same system of units. So It's already like that. So 1200 ohm is also the SI unit, ohm, SI unit, volt. So that's fine. So I1. 0, 0 cancel, then 2 6 are 12, 0. We're using 2, so 2 ones are 2 ones are 2. So we have to divide the 11 by 60. So follow me. 11 is less than 60, so we put 0 point and increase one digit here, right, with a 0. We know this division. Quite simple, 1, 1, 0. Okay, so 62 is too much, 120, so 1 will go. Remainder is therefore 11 minus 6, 5. Then decimal means we're allowed to put here 1. Now 8 will go, I think. 8, 0, 0, 0, 8, 6 are 48. 9 will be too much, so here 0 and 20 remainder. So another 0, and I think 3 will go. So 3, 0, 3, 6 are 18. So we can stop there. Usually we go up to third place of decimal. After point, this is called first place, second and third. Okay, not rule, fast rule, hard and fast rule, but usually textbooks solve that way. Okay, so going to the third place, 0.183, and we know the SI unit of current is ampere, meaning volt divided by ohms is always ampere. So the current here is this much. So the purpose of going to the third place is we can take approximation. Approximation means we look at the third place. If the third place is 5 or more than 5, then the second place of decimal will increase by 1. This 8 will become 9. But less than 5, 3. So this will not change. So we just write the approximation up to second place. 1.8 ampere is the current flowing approximately. So we'll write our answer. Therefore, current here is, you can just write your own way, current here, I1 is equal to 0.18 amperes. First answer. And let's go to B. B here, let's read the question, same method. How much current? So I2, let us put this time because we've already used up. Will electric heater coil draw from 220 V? Same V, but let's just put 2 if you want. And the resistance this time has changed to 100 ohms. So R2 is now 100 ohms. We're going to do by the same method. That's why I'm just using. So since using Ohm's law, you do like that and just change the things. V2, I2, R2. Then I2, V2, R2. And from here we can just rub it out. Then here we write down V2 is 220 volts divided by R2 here 100. So this is very easy now. I2. So 0, 0 you cancel. That means the decimal is after 22 here. So 1, 0 means decimal will move to the left of the first 2 here. So it will become 2.2 volt by ampere, SI unit of current. I is current, so we know. Since this is current, we know to put here ampere because current SI unit is ampere. So here, current this time here, in the B case is current flowing here. I2 is equal to 2.2 ampere. I hope you're getting right. Okay, that's good. Now, let us go to the next one, 12.4. Example 12.4, page 219, same page. So in this numerical section, primarily we're going to use only up to the 4 formulas here. More will come as we go on, but we'll slowly add them, okay? We read the question. The potential difference between terminals of an electric heater is 60 volts. So let's start writing. As we read the question, we found out the potential difference means this one. 60 volts is the potential difference. When it draws a current of 4 ampere, so let's just write down okay, V1, I1, let us put 4 ampere is the current flowing in the first case. What will be the heater? Okay, so let us solve this part. So here resistance is not mentioned. Let's just put it ourselves. It's the same heater, so R is the resistance of the heater. Let us say resistance of the heater means the heater coil, heater wire. Now, since using Ohm's law, we can simply use V1 equal to I1 into R. That's the appropriate formula. That way we can get this R equal to V1 by I, because we know V1 and I are already given, so we want R. So that is 60 volts V1, I is 4 ampere as the resistance. So 4 ones are 4, 2 in hand, 4 5s are 20. So this will be 15, and we know the SI unit of resistance, get it today, is ohms. We can write like this, or in short, omega, small Greek letter I think. So ohms. Volt by ampere is always ohms, SI unit of resistance. So let's keep this one as equation number 1. Let's go to the next case, and then the next part is saying here, let's just write in the format of the question, what current, let us say I2, put it ourselves. In this format also we can do. Will the heater draw, means will the heater draw, means this is the same heater, right? Heater draw if potential difference, let us say V2 is increased to 120 volts from 60 volt, it has increased this one. So since it's the same heater, R will be same. So okay, so you can just write here now, since it's the same heater, R will be same, R value will be same. Therefore, again using Ohm's law, in this case here V2 equal to I2 into R, not R2 but R, because it's the same heater. So we write that one. Then we can go here. What current will it draw? So I2, don't shift that. Then V2 divided by I2. So V2 here is increased to 120 by I2. Oh, sorry. R, this is R, sorry. R will be shifted. R, right. So resistance is the same, this one, 15 ohms, because the same heater, I2. Since using equation number 1, let us say like that. So therefore, this one if you cancel, 5 3s are 15, 5 2s are 10, 11 12, 5 4s are 20, 3 8s are 24. So I2 will be equal to 8. SI unit of current is ampere. We know volt by ohm is ampere. Therefore, current drawn they're asking for I2 equal to 8 ampere. That's our answer. I hope you're getting it right. So 12.4 is done. Let's go to 12.5. Not hard, 12.5, but listen carefully, a little bit longer than first two. So let us say example 12.5. Let's read the question carefully and go slow. Resistance of metal wire. So here 1 meter, 26 ohms at 20 degrees Celsius. So here our information at the same temperature, 20 degrees Celsius. Resistance of wire of length 1 meter, so length is L. I'm going to use this formula here, L, length 1 meter, that's fine, is the length of the wire. Let us say this is the wire L. So this is the length of the wire. This is fine because SI unit of length is meter, so that's fine. Now as we go on, 26 ohms, so that is talking about resistance. Whenever we see ohms, there is resistance. 26 ohm is the resistance of this wire. Okay, so R is the resistance of this wire. Then if the diameter of the wire is 0.3 millimeter, diameter means circle, every wire is circular, so diameter of this circle is diameter is 0.3 millimeter. That means the radius will be the diameter, the radius of the circle is diameter divided by 2 millimeter. You need to listen patiently here. It's not hard, but you need to listen carefully so you know how to convert. 2 zeros are 0, 2 ones are 2, 1 in hand, so point means 10, so 2 5s are 10, so you'll get this much. But the SI unit of length is not, radius is a distance, and SI unit of distance or length is not millimeter, so we need to convert to meter. So for that we are by now accustomed, but let us go through because we need this almost many times, so better to memorize it thoroughly. Kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. Very absolutely important that we memorize this, okay, thoroughly. It's just like you have memorized English alphabets ABCD, that anytime you can just speak it out from memory like that, okay? So that thorough, I mean, as thorough as knowing the English alphabets. You don't need effort to recall the English alphabets because you've used it so much, you've memorized it so well. Like that you do it, I mean to say that, okay? So millimeter has to be changed to meter because the SI unit of length or distance is meter. So how many places you are shifting? 1, 2, 3, and we know each place is 10, so 3 tens are there, which means 0.15 has to be divided because you are changing small to big. Had you been changing big to small, you would have multiplied, but you're changing a small millimeter to meter big unit, so by 3 zeros. So we know that when we divide by zeros, decimal move left, so we'll start counting from original place here. 1, okay, 1, 2, and 3, because there are 3 zeros, so the decimal has shifted 3 places. This much meter is the radius. Not hard, just listen. Now usually we express units in most textbook, which is not a hard fast rule, but an accepted standard form. So standard form is always decimal shift to the first digit, okay, apart from the 0, so after 1. So you're moving 1, 2, 3, 4 places, so 1.5 you will get. For that you will have to divide by 1, 2, 3, 4 shifted to here, so 1, 2, 3, 4 zeros. Then if you divide, you will get back this original. So this one, or writing this way, we mean to say is that you write like this or you write like this, is the same value or same meaning, right? So here we write, I'm just expanding it so you understand it well. Now here we know 1, 2, 3, 4, 0 means we can also write like this also, 10 to the power 4. You know that. 10 to the power 4. 1, 2, 3, 4, 0 or 10 to the power 4 is the same meaning, I mean to say that. So 1.5, and if you shift 10 to the power plus 4 from denominator to numerator, the power will change to minus 4. So like this is called standard expression, which is not a hard and fast thing, but it is done usually like that. So I'm just writing like that. Okay, so once you're through with that, now let's go to the next part. What will be the, so this is nothing but the radius of the wire. Radius of the wire. Okay, so next here, what will be the resistivity? And you know resistivity is denoted by rho. This is called resistivity or specific resistance or resistivity. It is also called resistivity, meaning is same. So resistivity, rho, is a question mark. is the resistivity of the wire. The question is asking us to calculate what will be the resistivity of the metal wire at the same temperature. The next part, using table, predict what material is this wire. We're going to use the table later on. Wait. Now, we know, since the formula for specific resistance is resistance of a wire is for specific resistance into L by A. As you can see here, we're using this formula. So we want to find rho. So let's just write here rho. Then this will go up. So R into A divided by this L will come down. So we may as well write like this. Maybe you'll prefer to write like this. Rho is equal to R into A by L. Like this also you can write. Now here let us start writing. R, as you can see, is 26 ohms. Do slowly. And cross section means the thickness of the wire. Since every wire is circular, so it will be the area of the circle thickness. So that is pi, area of the circle is pi r square. This circular wire. Cross section means this portion, as you cut like this, and this portion, and this portion cross section is always circular for all electric wires, right? So that's why we're using pi r square. The area of a square is pi r square. So L is 1 meter, so that's fine, just put it. From here on, it's a matter of doing patiently, not hard. Just write this one, 26 ohms into pi, we know is 22 by 7, approximate value. When it's not given, we put that. And R has already been found also, but it's R square. So here, let us write down. R square means 1.5 into 1.52 times, because it is square. And this also 2 times, so 10 to the power minus 4. 4 2s are 8, because it is square. Okay, so let's write like that. Then here, meter should also be square, because R square. So meter into meter, we write here meter square. I repeat, pi already there. R square means 1.5 into 1.5 into 10 to the power minus 4 into 10 to the power minus 4. So 10 to the power minus 4, 10 to the power minus 5, 2 times, just multiply the power also. Okay, 4 2s are 8. And here meter into meter is meter square, because this R square divided by, we shouldn't forget this one, 1 meter. So once we are done with that, we can see that this meter to the power plus 1 cancel, and power here 2 minus 1, so still 1 more left. Now let us multiply these parts. These 2 multiplied, we know from our memory also, we know that 15 into 15 is 225. So 2 decimal place, 1 2, so 1 and 2. Then let us multiply to this 26 first if you want. 6 5s are 30. 2 are 12, 15, 6 2s are 12, 13, 2 5s are 10, 2 2s are 4, 5, 4. So 0, 5, 8, and 5. 1 2 decimal place, so here. Which means 58.50 means you can neglect a 0. No need to take that. So we've done up to here. This done. So let's multiply to this. So 22. So when you multiply here, we are going to get 2 5s are 10, 16, 17. 1 in hand, 2 5s are 10, 11. So here 0, 7, 8, here 2 and 1. 1 decimal place, so here. When we multiply this, and this, we're getting equal to 1287.0, means no need to write that. So up to here, divided by this 7 into here, only this one left, 10 to the power minus 8. And then here ohm is there. And the SI unit of specific resistance is always ohm meter. SI unit of resistance is ohm. SI unit of specific resistance is always ohm meter. So it's coming out correct. See here, ohm and meter. So now we have to divide this. Matter of doing patiently, that's all. Now here if you divide this, 1287 is divided by 7. 1s are 7, so 5 remainder, 8 coming down, 7 8s are 56, 2 remainders, 7, 3s are 21, 6 remain, 0, 7, 8s are, I think up to first place will be enough because we're going to go to standard form, bringing the decimal back here again. So 183.8 is what we get when we divide this into 10 to the power minus 8 ohm meter. We're almost there. But as I said, usually our answers are expressed in standard form. So after the first digit between this 1 and 8. So if you do that, you're going to get 1.838 decimal shifted, means 2 places shifted. So 10 to the power 200. 10 to the power 200. Then only what we mean to say is 183.8, or writing 1.838 into 10 to the power 2. This and this are same. Think about it. If you multiply again, it will come back to this, to 2012. So I'm just showing the steps so we get to comfortable with it. So this is not touched to 10 to the power minus 8 ohm meter. Okay, next step. So we can write here that will be equal to 1.8. Then look here. Third place is 5 or more than 5. Then the second place of decimal will increase by 1. So 3 plus 1. That's why we're going to third place into 10 to the power, let us write this one first, minus 8, and let us shift this 10 to the power plus 2 to the denominator. Then the power, the sign of the power will change to plus 2 to minus 2. That way we can ohm meter here. We can cancel this 10 to the power minus 2. Minus 2 gone means still 6 is there. Minus 2 cancelled. So we're going to get our answer is approximately 1.84 10 to the power minus 6 ohm meter as the specific resistance of this unknown wire so far. Now comparing this raw value to table or with table. The question is saying table 12.2 textbook page 218, go there. There is a table. Which material has this value? Go there. And you will see there 1.84 there, manganese. Page number 218 at the bottom there is a table. So we can write your final answer. We see that this material of the wire is nothing but manganese. Full form, and if you want to write a symbol, M capital small n. Okay, so that is done. So once we're through with that, one more question, 12.6. Let's see what time is there or not. Yes, I think we can do it. So let us do 12.6. Here, example 12.6. Let me read the question. A wire of given material length. So here L is the length given. You can do it simply like this. So this is case 1. Let us say case 1. And cross section A. So A is equal to, that means thickness of the wire. This is the wire, let us say. A is the cross, so L. Cross section means thickness. Then has a resistance of 4 ohms. So let us write here R equal to 4 ohms. R1, 4 ohms, let us say. What would be the resistance of another wire? So that is case 2. So here rho is question mark. That is this resistivity. Textbook is calling it resistivity. It is also called specific resistance. So we write here R1 is equal to rho into L by A. So that gives you rho equal to R1 into A by L. This will go up, this will come down, right? So Rho will therefore be R1 here, 4 ohms, into A is A itself, L is L. So let's just keep this one as 1. Now go to the next part, and we'll see here. So case 2, let's write here case 2. Next sentence, what would be the resistance of another wire? R2, question mark, resistance of second wire. Okay, having length, so L by 2 is the length. That means this wire is shorter, half of this, L by 2. And cross section 2A, so it is thicker, much more thicker. 2A, so 2A is the cross section. So since the second wire is also of the same material, question is saying like that, same material, therefore, so its resistivity will be same, that is Rho. Remember this, wires of the same material always have same resistivity. Okay, so resistivity, so let us remember that and do this. Therefore, applying the formula, R2 just like this, Rho, same Rho because it's same material, into length of the wire, this time is not L, L by 2 on the numerator, following this, A is 2A, we put like this. Then we can write here, Rho here, see, 4, since it's same value, ohms into A divided by L. So that's what we're getting. Into here, this part we can just write it, and this long line, 2A means 2A by 1, so into means 1 will go up, 2A will come down. You can write here, since using equation number 1, we have replaced this Rho by 4A into A by L. So now 2 2s are 4, 2 and 2 cancel, A and A cancel, L and L cancel, so nothing is left. Here 1 ohm. So the resistance of this second wire is 1 ohm. That's your answer. So now you can go and give the test, okay?